Okay, so what we got here in the RIPS is the application of a tool like draft. Then once we do the draft analysis, we can start with shelling. Later you'll also learn in this particular lesson of how to create new planes. That's a part of your reference geometry. Then once the shelling is done, then you can apply to use some of the RIP tools. Part of the lesson you'll also learn about thin features. Okay. See, unexpectedly we might have done with the extrude sometimes with the thin features, which is an option for revolve as well as an extrude. Okay. But you could ask a question like why we need to check for a draft, for example. What is draft? Okay. What's the importance of the draft analysis before we further go into shelling? Okay. And the other important stuff would be in the lesson 7 would be the creating of the planes. Okay. The basic things to create the planes. You could start with using a 3 vertex points, or you could start with the existing planes parallel to it, perpendicular to it. We often add these ribs, very thin sections in the part. Okay. The advantage with this feature rib tool is again you are drawing a line entity, using that line entity to extrude. The overall in the lesson 7 there is one more important thing that you will be learning with the sketch tools is convert entities. So that convert entities will allow you to copy edges on a particular face or a particular plane, or even projection as well. If you want to draw an existing edges being drawn to a new plane, all you need is to activate the plane, sketch it, and copy the edges onto that plane, new plane created. Quite important tool. Convert entities will help you to not to draw your sketches from the scratch. Existing part, existing model, if anything is useful of the edges, offsets, mirrors, you can always use convert entities. These are quite useful tools of the sketches. So what we are heading actually in this from the lesson set, from your using these options, the important thing would be your display or delete relationships with your sketches. We moved into this. Now we'll come into some evaluation part. Okay. The part is given. You might have seen in the simple study that how do you evaluate the once we assign this particular material with this part with the material. Okay. A simple draft analysis here. Activate your this the top face. You can activate that one and just check the draft analysis. So what you can do, what you have is normal to this plane. You can change this direction. You can change the direction here. But normal to that plane, I want to check the other edges, how they are actually deviating. And there is a color identification for them, which is a green for positive draft, yellow for if the edge is
drafting.
Exactly, and the acute draft. Okay, so you can calculate it, so it gives you the edges. Okay, so basically saying me that these particular edges, the yellow will require a draft, others they have some positive draft. Okay, you can check for a degree alignment. You can increase, decrease these degrees, so that you'll know within that what range the variation is happening. Okay. So he's asking you to set the angle to 2 degrees, 3, you can see, you need to set the angle to 2 degrees and recalculate this one. So you'll end up, see, if I make it to 2 degrees, there is a edges here on this side. But if I go 2 degrees and calculate, that edges are gone. So only these edges now, they need to be manipulated, because these with the shelling, when you are shelling inside the part, the edges, they need a consistent distance. If there is if the part doesn't have that consistency, it won't do a shelling. It will reject the shell operation. That's the thing draft analysis is consistently used. Draft also could be used for any fits, for example. If you have a very close fit, some of these drafts, say for example, if you align this one also to a norm, it's very hard to see the edges. Say for example, if you try to do it from here, it's a very small draft, this edge and this edge, but when you have that needs to be made changes, so what you now you can go into your features of the feature bar. Then you need to insert, in this case, 2 degrees. And you need to select the edges. So this is the edge. This is the, sorry, this should be the normal. Three edges, 3 faces, please. And you need to apply for all of these 2 degrees. Once applied, once selection is made, you can just apply it. Go back again for evaluate and do a draft analysis one more time, selecting the face and calculate for 2 degrees. So I think I made a positive draft. There should be a negative draft for that side. So that's the way the draft analysis will help you. There is already a draft there. You can go and edit the features. So yeah, just reverse it. So everything is fine now. So you should get the undercuts or the faces, all the faces, they should be red. Okay. So once you finish this analysis, part has some consistency, you can go into your features and start shelling it, please. Shell, select the top face. All you need to apply a shell of thickness 1.5. Okay. There are a few options: shell outwards and shell preview. Show preview. You can see the preview here. Okay, but to the shelling, you want some of these faces to be removed. So you need to the unaligned faces, excluding the top. Sorry, including the top on the other end. So select the faces. See, other thing you can use is the select tool, please. When you're trying to choose, there is an option for you for select tools. I can go and edit this one anytime I wanted. I can keep editing this one. I can activate this box and select the cells. So when you are here, select the faces. to add 9 faces for the moment. Okay. So you want those faces to be completely removed. I wanted to show you the tool which is select others. This comes with a mouse and a goggle man there. Sometimes it is very hard to find the edges inside the part. You can use this select others tool. Okay, so you can if you right click the mouse, it will go inside and give you more of the faces. When you actually go into an assemblies, it's very hard to look at the edges or faces or vertex points. So select other is a tool that will go inside into your part and show you the edges on the surface on this particular okay. So once this is done, you can say yes. So this is what you should have in the end with a shell. Once this is done, I'll quickly show you how you can add planes using a geometry plane. So for your normal plane, you need to have at least 3 references. Say if you are using 3 vertex points, so in this case I can select a vertex point, say here. It won't draw a plane, please, it will just draw a line, so, or an axis points. I join. It's easy to insert a plane parallel to existing planes. Front plane. So in this case, he will ask you to plane top plane at a distance of 10 millimeter below. You can also create a plane perpendicular to this. Okay. Actually will be gone. You can also create a coincidence. You can also create a mid plane. Okay, so these are the few options you ought to use your plane fully constrained. But if you are using edges, say for example, I'll clear this one. Now I'll use the same top plane, but I want this one to be at an angle. Reference, it automatically, your identification of your references is done by these colors, please. Okay, so in this case I want to use a second reference. Maybe I'll use a sorry, I'll just delete this one. I'll use an edge instead. Second reference, that edge angle. So my plane is actually now so you have to use sometimes planes will be very useful for you to draw your new sketches. The existing base planes might be somewhere else, and you want to draw it at another point. other location, then you need to create these planes. Reference geometry is a very important tool in terms of making your features, new features. Observe this, because your exam will include all of these. If you don't know how to create a plane, you are stuck. You can't proceed. That plane, I won't ask you to create a parallel plane. I'll ask you to use some edges and insert a new plane. On that plane, please insert a sketch and extrude or use some revolve feature. So your exam will be a bit complicated in terms of what you are going to make. If you don't know how to use these, if you haven't gone through these, you will be in trouble. It's an open book. You can bring your notes, any other material you wanted, but I said clearly you can't quickly find an answer by using a Google. I won't allow you to use a browser. Okay. Of the notes, go to your index. If there is something with the creation of the planes, go to that particular page, have a quick read through how this plane at an angle is inserted, then just imitate that one to complete your part. Okay. It's your technique I am going to, how you're going to complete the part. Okay. So that is where you can add your one with a vertex, and so the simplest, for example, using the existing planes. So let's here, yeah, we have is active at a distance. Always go and edit happy feature. Okay, it doesn't become fixed plane. You can always go and edit it. The plane, he wanted you to draw two lines. Okay, so activate bigger. So all on this plane, you, okay, so on normal if you wanted. So select a line entity, place the lines, because now we are going to use the rib feature. For the rib feature, you don't have to coincide your end points. Then so this should be 5. Then you can go into your features and activate your rib. Okay, so the and check on the direction. Parallel to the sketch, you don't want that. You want it to be a normal, but in the reverse direction towards the object. Say yes. So a shell is being added now. And I will quickly show you how to use a convert entities on the same plane. Say for example, on the same plane, I'll go into that as a sketch. Okay, so I can go into activate my convert entities. All I need is projecting those edges onto this new plane. Okay, so these edges, the pattern edges, whatever they are, they have been projected now onto the plane. Say for example, I'll go into same convert entities. I'm still in the sketch. Convert entities. I wanted for example, say yes. Created for me on the plane. So it's an orthogonal projection on this new plane. Convert entities. This sketch face of the but if I go and all I wanted to convert this particular delete the relation deleted, then you are here. Just you want that one to be a vertical line. Sorry. Midpoint of that. So there should be enough for you to draw one more rib here. So there should be enough for you to draw one more rib here. One more rib here. Activate your draft. See the side. Actually, I'm on the wrong side. It should be drawn. The rib should be drawn here on this side. You can complete entities on the same plane. Maybe this might be a bit higher. On the same plane, convert this particular edge, removing the relationship into the center, and create two ribs here on this side of the cut and on the other side of the cut here. Okay. And the last thing would be in this particular lesson is to use the thin features. So before that is a full round fillet. When we particularly create a full round fillet, you don't have to specify any radius, so it's a round fillet. So thin features, all you need is if you are activating a revolve thin line, and it is going to be a symmetrical object along this axis, all you need is activate into your features revolve. This line will a revolve thin feature. Thin feature is basically here, it is checked here. So apply the thickness here for whatever the thickness is specified in the model. It looks like a ratchet head, so it has got certain thickness, and apply that thickness, and you can also use the direction or the mid plane. You can eliminate that. Okay, along the extrude. So I'll go into this extrude boss. Say for example in your idle arm, for example, you have drawn the full section, then you have an advantage. You draw only one